All right, 10.4 nets and surface area. Students will be able to use nets of 3D figures and formulas to calculate surface area. So what is a net? A net is what a 3D figure would look like if the sides could be unfolded to create one 2D shape. So imagine if you had, real quick, a cube. Okay, one of the most basic 3D figures. And if you were to unfold this, well, you'd have your bottom, and then you'd have your sides, and then attached to one of these sides, you'd have your top, right? And then these would all be sides. And so, I know my drawings are pretty great, but hopefully you get the idea. That's what a net is. It's just a 3D figure with all the sides unfolded. So, example 1 here says, which net could be folded into a pyramid if folds are made along the dotted lines? Well, feel free to pause and just take a look at this for a second, but I'm going to try and explain it to you. If you look at it, you can hopefully see that the square would be the bottom, right? That'd be the base. All right, there's the square. And if you fold this side up and this side up, right away, hopefully you should see that these two sides here would overlap. And same thing when you fold these up, these two sides here would overlap. And we don't want any sides overlapping in our net. We want all the sides to be represented. So we would have these two would overlap, and then we'd have a hole like over here somewhere. Or these two would overlap, we'd have a hole over here. And on this one, we would see that this top one would actually overlap with this one over here. So we'd have a hole on the side. And finally, this one would work, because each one of these sides would go along the edge here. And so no two sides would overlap, so it would work perfectly. Okay. Now let's talk about surface area. So surface area, this is the sum of the area of each face of a solid figure. So, for example, in this cube up here, the surface area of this cube is the area of all these parts added up. So this would just be 6 squares, right? Because there's 6 squares. So the area of one side times 6. But it gets a little more complicated as we get more complicated figures. This here is a prism. On the next page, we're going to break down all the different shapes for you and all the different formulas. But I want to show you guys how you can draw the net for this and then use it to calculate the surface area. So let's just try and draw the net. There's not enough dots here for each dot to represent 1 centimeter. So we're going to have every 2 dots, or I'm sorry, every 1 dot represents 2 centimeters. So if we do that, I'm going to draw a line right here. 1, 2, 3, 4, 5. I think I drew too much, but that's all right. That's going to be this line right here. Okay, so that line is 10 centimeters, so it should be 1, 2, 3, 4, 5. Yeah, sorry, I did draw a little bit too big. Now, if we think about it, this side here would fold down. Now, before we do that, we got to figure out what this height is. Well, that should be pretty easy, actually, because we already know that this hypotenuse is 13. It says that it's a right angle. So this is actually one of our triples, and we have a triple of 5, 12, 13. So I actually already know that this is 5 centimeters because I know my Pythagorean triples. So that means if I was to unfold this side here, fold it down, I'd have 5 going back this way. So let's go ahead and do that. So that'd be, if 5 in dots, right, that would be 2.5 dots because every dot is 2. So 2, 4, and then 5. So we go about halfway. So we could write that's 5 and that's 10. And so that represents this side here, unfolded. Now let's draw the base. That's 12 by 10. So here it's going to be 6 dots. 1, 2, 3, 4, 5, 6. And 6 this way. So that, because that represents 12. And this again is 10. And then we have these triangle sides here. And this technically in a prism would be the base, because the base is the non-rectangular parts. And we'll talk more about that. But these would be the base of the shape. So we could draw that out. That looks like it's going to go up 5. So we're going to go up 1, 2.5, because for each of these is 2. Boom. Same thing here. Boom. So these are these triangles just folded down. And again, then this would be 5. This is 5. This is 5. this is 12. And that hypotenuse is 13, but we don't really need that for this thing. And lastly, we're gonna take this top part here and we're gonna unfold it out here. We know that it's 13 long by 10, so 13 would be 6.5 dots. So 1, 2, 3, 4, 5, 6.5. Okay. All right, so now we've got this thing all unfolded. We got the net of this figure. So we got this net of this figure here. And so now what they want us to do is use that to calculate the surface area. Well, the surface area is just all these parts added up. And the cool thing about making a net here is we could just kind of make this into one big rectangle plus two triangles that are the exact same because they're both 5 by 12, 5 by 12. So if we think about that, we got one big rectangle plus, and I'll do these guys in red so we can see them, plus two triangles. So that's pretty easy. This big rectangle is going to be 5 plus 12 plus 13. Well, let's do 12 and 13 together first. That's 25 plus 5 is 30. So this is going to be 30 times 10. The triangles, they're 2. There's 2 of those, but remember for a triangle you always do 1/2. The base is 12, and the height is 5. So we got this. 30 times 10, that's 300. And the 2 times the 1/2, that kind of cancels each other out. All we have to worry about is the 12 times 5. 12 times 5 is 60, so that's 60. So my answer here is that this is 360. My units was centimeters, so I'm just going to write centimeters squared. And so that's an easy way that you can always find the surface area of figures. Just kind of unfold it and draw the net. All right, let's go to the next page. All right, on this page, I want you to take some time and just look over it. But what I have here basically is formulas for a prism, cylinder, pyramid, cone, and sphere. And in here we have surface area and volume formulas. So I have no problem with giving you guys these formulas on the actual test. However, you do need to know how to use them. So we need to know, for example, what the P is and what the B is. And so I define those terms for you here: perimeter, base. So a couple things about that. The base is always the shape that's not a rectangle, at least with a prism. So notice this is a hexagon prism. So the hexagon is the base, and all the other sides are rectangles. Or for the cylinder, the circles are the base, and if you unfold the sides, it creates a rectangle. Pyramid, the sides are triangles, and so this would be a square base, but you could have a hexagon base or a pentagon base. For a cone, the base is a circle, and for a sphere, there is no base. So we really need to know how to use these formulas. And one of the interesting things about these is each of these formulas, especially for the prism and the cylinder, they give you the, well, what is a term, we don't usually use it on con, but it's just still a geometry term, is they give you the lateral area plus the area of the bases. For example, here in the prism, the perimeter means the perimeter of the base. So if you notice, the perimeter of this hexagon would be the same thing as the base of this triangle, lowercase b base, or this distance here. That's the perimeter of the hexagon. And the height would be right here. So if I wanted to, I could put a little h here for the height, and I could put a p here for the perimeter, because that's the perimeter of this hexagon again. When it's unfolded, it's going to look like this rectangle. And so that's where we get this perimeter times height. That little part of the equation is just the lateral area. Then we add the area of the two bases to it, and we get the total surface area. Let's say we're doing with the cylinder, very similar. If you unfold the cylinder, you have two circle bases, and the whole sides would unfold to be a rectangle. Well, look what that gives you. That gives you 2 pi r, because it's the circumference of the base, times the height. So again, this is just the lateral area plus the two bases, pi r squared, pi r squared. So that's where these formulas come from. And that's important because sometimes they're going to only ask for the area of the side. And if they only ask for the area of the side, then you really only need this part of the equation. You don't need the top and the bottom. Or here, you only need this part. You don't need the top and the bottom. Or here, the 1/2 PL. That's these four triangles, 1/2 PL. That's where we get that from. You may not need the base area. So it's important to recognize how these formulas work so that if I ask you for, say, just the sides, you know it's just this part of the formula and you don't need the B part, okay? So that's important. So familiarize yourself with these formulas, try and see if you can figure out where they got them from. The same thing down here with the cone. This pi RL, there's an interesting proof for that, but that's just this part. This whole part is pi RL, and this part is pi R squared, okay? I might just put that in here for you. So again, I defined what those variables mean here. You got R for radius, L for slant height. They tell you what the slant height is over here. It's just the distance from the top down to the side. So all these things are defined for you, but I would definitely spend some time taking a look at this page because there's just some valuable information here needed to be able to solve all these future problems. That being said, now I'm going to go on to the next pages, but I'm going to be referring back to these formulas throughout the rest of these notes.